How's it going, everybody? In this next video, we're going to take a look at switching the logic around a little bit and focusing on something a little bit new, which is the interface pseudowire. So I've never really gone into a whole lot of detail on how that stuff works, but when I've configured the L2 xconnect context, when we go in and set the member up, we've always called an IP address. So we're basically relying on an auto provisioning of the pseudowire. The only drawback to that is it doesn't really give us any flexibility in terms of what the pseudowire is capable of doing. So in this video, we're going to take a look at manually creating the pseudowire and defining what it can do. We'll take a look at some more advanced capabilities down the road. But the idea is when you have the capability of modifying how the pseudowire works initially, it makes things a lot easier to scale and work with long term. So let's go ahead and take a look at how that actually comes into play. I've gone ahead and I actually deleted the config from the last video, so we're starting off from scratch, but the service instance is still there. So I didn't get rid of that. I just got rid of the L2 xconnects because we need to go in and specify pseudowires. So I'm going to first specify one, and then we're going to add in a second one like we did in the group in the previous video, and how that comes into play. Alright, so the first thing we need to do is do show run interface gig 3 just to validate, or sorry, gig 6. The service instance is still there, right? Now what we're going to go do is type in interface pseudowire, and we're going to have to give this a number. So in this case here, I'm going to type in 10, and underneath here we have a bunch of different options, right? I'm going to first specify the encapsulation. Whoops. The encapsulation is going to be MPLS, and then I can define who the neighbor is. Notice how I get a lot more options when I do that. Now I'm going to type in the neighbor is going to be 10.0.0.1, and the VCID is going to be 10, and then I hit the enter key, right? So I have a bunch of other options that are available to me as well. So I can configure static labels, I can do a whole bunch of different things. So the next thing we're going to have to go do, and to keep this thing very, very simple, is I'm going to exit out of here and go create the next pseudowire. So do show run interface pseudowire 10. That's the config. Very, very simple. Type in interface pseudowire 11, encapsulation MPLS, neighbor of 10.0.0.1, 11. Okay? Now I have my pseudowires created. Now whatever you configure on one side needs to match on the other. So I'm going to do the same thing on the other side, except for I'm going to go type in interface pseudowire 10, encapsulation MPLS, and the neighbor is 10.0.0.3 and 10, and do the same thing here, 11, encapsulation MPLS, and then pseudowire of 11. Okay, now we have to go, we've got the pseudowire, so do show IP interface brief. The pseudowires don't show up, right? We have to go underneath the L2VPN xconnect context, and we're going to call this VLAN 10 with pseudowire. I'm going to type in member is going to be gig, in this case here it's going to be gig 3, service instance 10, and then we're typing member, and then this time with pseudowire, and then the number 10. And you'll also notice that we have 1 through 100,000. When you're doing manual configuration of pseudowires, your upper limit is 100,000. Dynamically created pseudowires start off at 100,000 and work their way up. So we'll see this when we get into BGP auto discovery for VPLS and stuff like that. But for the long term, that's basically what your limit is 100,000 pseudowires. So we're going to do that, and we don't have to specify the address because it's already been defined. We'll do this, and we'll do 11, right? But now it says member has invalid redundancy group, because you can only have, in order to have a second pseudowire in there, you need to have a group. So if we do show run section L2VPN, you're going to see that only pseudowire 10 is available. So we're going to roll with that for just the time being. I'm going to go ahead and go over to CSR3, and L2VPN xconnect context is going to be VLAN 10 underscore with pseudowire. Then it's going to be member of gig 6, service instance 10, and then member pseudowire 10. Okay, I'm going to exit out of here. and I'm going to exit out of here. That should do all the provisioning that I needed to do, and there we are. We're up and running, and everybody's good to go. We're going to give CSR3 a minute to finish its thing, and I'll bring you guys back in here in just a second. Alright, so now that that's all squared away and everybody's happy, so we're going to do a show MPLS L2, or let's do a show L2VPN. We'll type in Atom VC. We can see that it's up. If we do detail, we can see that it's up and it's working the way that it's expected to, which is a really good sign. So now we can test connectivity. Can we, from router 1 to router 3, can we ping 10.1.3.3? You bet your bottom dollar we can. That's a good sign. So now we're going to add in pseudowire redundancy. So we're going to go back to CSR3. We're going to go to global config, do show run section L2VPN. And then we're going to come in here and I'm going to remove this line. So no member, pseudowire 10. And on this side here, I'm going to do the same thing. So underneath here, we're going to go ahead and remove it. And hit the up arrow and type in no. And it'll be member, pseudowire 10. And then the group will be group. And then the priority will be 10. And then we'll do 11 for pseudowire 11. And I'll do show history. And I'll just grab these few lines of config, jump back over to CSR3, copy and paste, and there we go. So that's how you get those connections up and running. So that should go through the provisioning process, which it does. And it looks like everything's going to work the way that it's expected to. We're going to have to give that a couple seconds for it to do its thing. And on CSR1, we actually have to, remember, you have to exit out of the xconnect construct config or else it won't work. So we'll just exit out, and then that'll automatically start the signaling process and things like that. So very straightforward for the most part, as you can see. Not too terribly difficult to get it up and running. It's just understanding the constructs is important. So there's that. All right, so the VCID is up and running, and we're all happy there. So show L2VPN Atom VC. We can see that the connection's up, and the pseudowire for VCID 11 is in standby. So that's working as well. So that's basically what we have to work with and the operations for that. Alright, so since we have that going, let's go ahead and do our ping test, which I think I already did. Okay, cool. So we did the ping test. Everything looks good to go there. So now we're going to switch gears and look at the template. So on CSR1, the template is actually pretty cool. So we have to come in here and type in template and type pseudowire, and the name is going to be, type in pw underscore temp and hit the enter key. And underneath here, we have to specify the encapsulation. So we can, there's not a whole lot of other stuff that we can do until we do that. So encapsulation and MPLS. And then if we do, you know, we have a lot more options here. Now this is where the rubber really meets the road for us in terms of what we can do. So we can turn the control word on and things like that. If we were to do a show run all section template, right now that's all we've turned on, right? So we just turn encapsulation MPLS on. If we do a show template and hit the enter key, this is where we associate stuff, but there's really not a whole lot more detail that we can look into to understand what's happening. So underneath the template again, we can do things like, if you wanted to do the preferred path with MPLS traffic engineering, so if we were to do this, we could type in the output interface. We could specify it would be tunnel, and then whatever the tunnel is that we're going to associate towards. This would be an MPLS traffic engineering tunnel. And so far, we really haven't dove into MPLS TE yet, so we're going to divert away from that specific config. What I'm going to go do is, is jump out of the way. I'm going to do things like the signaling protocol will be LVP. The status will be turned on, and then we're going to do redundancy, and then we can say master, put the xconnect redundancy group on this node in master node. So we'll just do that. And then there's another so sequencing is on too, sequencing, and we can type in both and do that. And we're going to type in load balance. We'll type in flow, and then we're going to specify the monitor up here and BFD, and we'll specify the local endpoint, so local interface, and we're going to specify so it's interface, and I believe it's pseudowire. Let's see. 1 second here. No, it doesn't do pseudowire, sorry. We could match on the, we'll type in, this is CSR1, so this would be gigabit 3. And so in the event that something happens, we should be able to bring down the connection and stuff like that. So we're going to do away with this. So do show run section template. So there's quite a few things that come into play here. So then we have to go create the pseudo wires now have to be reconfigured. So do show run interface pseudowire 10. So interface pseudowire 10. And then underneath here, we're going to say the source will be template of type pseudowire, and the name is going to be capital PW underscore temp. And then on CSR3, we can see that it's automatically starting to do a bunch of stuff. So it's turning stuff on and off, redundancy group down, and stuff like that. So we're going to have to go to pseudowire 11, do the same thing, and get that guy going. So CSR3 is getting updates because we're negotiating now. We're renegotiating the in-place pseudowires that are happening. So what I'm going to do is do show run section pseudowire, or do just template. And we're just going to grab this template right here, and we'll drop it up to this point here. And we'll swap the gig 3 out for something else. So I'm going to go to global config, copy and paste that in. But I'll come up here, and this will be a gig 6. So do show run pipe section template. Okay, so it swapped it out there, which is good. And then I'm going to jump into interface pseudowire 10. And then source is going to be template type pseudowire of PW, and I believe I called it temp. Yeah, CW temp there. And then we will give that a couple seconds to figure itself out. And we'll do the same thing for, well, unfortunately, it's a lot of output. So we'll do 11 and do the same thing. So that should fix our problems, hopefully. And we'll get out of here, and then underneath CSR1, we'll get out of those configs. And so we'll just go show MPLS L2 transport VC, and it's up, right? So that's a good thing. And right now it's trying to figure out what's happening. So ECMP is enabled. So we'll have to give this a second to figure itself out. So we'll do the same thing here. We'll do a show MPLS L2 transport VC, and they're up. Now if we scroll up here a little bit, you're going to see things like, let me find it. This is pseudowire 11. And let's go up to 10. 10 is good. So load balance mode is ECMP. And we can see that fast switchover is not enabled. The control word is enabled. It was down, but it is now, where is it? I just saw it. It should be up. So we should be able to go to router 1, hit the up arrow, and ping, and we can. So router 3 should be able to ping all day. If we do a show ARP, we should be able to ping 10.1.3.1 all day long, and we can. So going back to CSR1, if we were to do, and I haven't tested out the failover, but if we were to look at the detail, we're going to see that a lot of information is here. So if we scroll up to the top here, we can see that 16 and 48 is there. Preferred path is not there. BFD is on, so we have fast failure detection. ECMP is enabled. If we look through here, we can see that graceful restart and nonstop routing are not enabled at this point, but that's okay. We have the sequencing is send and receive, resync disabled, and everything looks good there. So if we do a show L2VPN Atom VC detail, we'll get a lot of the same stuff, same outputs. So a lot of the same stuff we saw in the other output is there, which is good. And everything looks pretty good. So my only thing that I'm not sure on here, if we do the L2VPN redundancy activate, let's do interface, manual switch over to a member by interface, interface, pseudowire 11. So that should work. So now if I go back to see this guy here and do a show L2VPN Atom VC, we can see, oh, it's probably still in switchover. Let's see if it's actually, it should be switched over by now. They're both in standby. It might take it a couple seconds for it to figure it out. Although it's saying standby. So if we go back to router 1 and we try to ping, the ping isn't going to go anywhere. So we might have to do this on this side too. So let's do an L2VPN redundancy activate interface pseudowire 11. So let's go back over to router 1 here. Okay, 11's now up. Okay, that's better. So once this guy is done, so it's both sides of the config have to be working. Or I should say both sides have to be switched over to the right. And if we look back here, now 11 is up, 10 is down. We go back to router 1, and the ping works. So we just did a group switchover as well. And so, which is kind of cool. We've also gone through and done, if we do a show run section, not on this guy, show run section L2VPN, we've got a redundancy group in play and a service instance deployed and all that type of stuff. Those are really the main things. We also configured a template, and it allows us to, configure things one time globally and then map them to the interfaces that they need to be associated to, instead of having to configure the same things multiple times. Obviously, templates are a good thing. Like peer groups in BGP or peer sessions and peer policies in BGP as well. Those definitely come into play. Or a profile. So a template is basically just a profile of config or smart port macros. However you want to refer to it, this is how you would kind of speed this process up. So it's my way of doing command line automation. So that's pretty much that. There's really not a whole lot more for me to demo in terms of the operations and that type of stuff. So with that being said, if we look back over at CSR3, we can see that the when you're doing the switchover, it's got to be done on both sides, and the operations have to be executed in order for them to both agree on that type of stuff. So that's pretty much it. There's really not much more for me to demo in terms of the operations. Now it's going to be, let's add more attachment circuits, and I'm going to have to do things like from CSR1, set up a pseudowire from CSR1 to CSR3 and from CSR1 to CSR5, where router 3 would be our endpoint, and then 3 and 5 would be our PE routers. So we have a diversified connections and that type of stuff, where We can do a bridge domain on this side and put gig 1 and gig 2 in that bridge domain and create a bridge domain interface. We're going to be taking a look at a couple different designs like that where we have dual attachment circuits. So right now we've only looked at one attachment circuit. We're going to add to our complexity and our redundancy and add in a bridge domain here because the iOS routers really don't support it. So I'm just going to go in. I mean, you could do an IEEE IRB group for a bridge virtual interface, but I chose not to go that route because it just I wanted actually to test out a port channel to where this guy's in a port channel and these guys are redundant connections and we're propagating MAC addresses a certain way. There's some advanced things you can do with multiple PE routers. So when you're doing a dual homed type of scenario where you're connected to 2 different PE routers for redundancy purposes, and stuff like that. So with that being said, ladies and gentlemen, thanks so much for stopping by and hanging out with me, and we'll catch you guys in the next video.